Good morning to you in Alaska. Good afternoon to the East Coast. Also participating, this is Pam Mendelson. I am with the Department of Energy, and I wanted to welcome you to a RACI peer exchange webinar and let you know that we will be holding on for a few more minutes as people sign on, and then we'll get started. Okay, great. I think we've waited a good amount of time and have let people sign in. So I think we'll go ahead and get started. I wanted to thank everybody for joining us. This is the second peer exchange webinar associated with the Remote Alaska Communities Energy Efficiency Competition, and we intend to continue throughout the year. Just need to advance that slide. Super. Before we get started with the content for today, I wanted to give you a few updates on the webinar operations. Everyone who's joined as a participant has been muted to prevent too much background noise from interfering with the speakers. At any time during the presentation, if you have a question, you can type it into the control panel on the right of your screen. There is a section that's marked questions. If you just click on the little plus sign next to questions, you should find a place to type them in. At the end of the webinar, we'll read off the questions and get some answers for you right away. Later in February, you can check the RACI website for a link to the recording of and transcription of this webinar. And we've given you the link for that. And we will be collecting information from you, anything that you believe should be announced or would be of interest to other communities in the state of Alaska. Please let us know and send your ideas or announcements for funding opportunities that you hear about to Fletcher Suba, and we will be sure to include that in future webinars as an update for everybody. So the goal of the Peer Exchange Network is simply to empower communities in Alaska and Native Alaska villages to develop effective tools to advance the use of reliable, affordable, and energy-efficient solutions, and hopefully ones that will be replicable throughout Alaska, other Arctic regions, and other remote places. The Department of Energy is very pleased to be able to leverage the existing convening power of the Alaska Energy Authority, plus other regional energy efficiency organizations, to form the backbone of this peer exchange network that we are building with communities. After today, we have a list of future webinar topics that include part 2 for the topic we're speaking about today, and some of the other topics listed here. And without further ado, I would like to transition and make an introduction to Jim Fowler and Lee Bolling, who will be our presenters today on efficiency, your first tool to reduce energy costs. So with that, I pass it over to you.
Hi, everybody. This is Jim Fowler. I'm going to take it from here, and then I'm going to hand it off to Lee. Let me make sure I have control here. I'm trying to do it. There we go. So there's 2 parts of this energy efficiency series, I guess you'd call it. Part 1 is today. Part 2 will be next month. Lee and I are going to talk to you about part 1. First of all, we're going to talk about the overall energy efficiency process, why we feel that energy efficiency should be first, what kind of potential savings there are, how does it compare to alternatives, and then the steps, how to get into an energy efficiency project, what kind of strategy needs to be developed, how is the project developed, financed, etc. And then next month, Amber Donahue from Siemens and Peter Beardsley from Nortec will be talking about project development again, financing, construction, and measurement and verification. So to start, this is kind of a schematic representation of the energy efficiency process. All of you have committed to a 15% goal reduction, which is great. So how do we accomplish that? The first step is to really understand what the building inventory is, and everything I'm talking about is on a community-wide basis. There's been a lot of activity in Alaska, a lot of energy audits, a lot of building by building or owner by owner initiatives in terms of energy efficiency, but we feel that the biggest impact would be if it was looked at from a community-wide perspective. So building inventory, let's talk about it. You have your own buildings or building, but on a community-wide basis, it would be best to have an inventory of all the buildings in the community. The next step is benchmarking and establishing a baseline. In order to establish a baseline, you've got to get utility consumption data, oil or gas in some of the areas. But mostly it's oil and electricity for a 2 to 3 year period. We'll go into that in more detail. And then there's what I call a portfolio analysis. Let's take a look at the buildings that you have, what they're consuming, what the baseline is. And then from there you move into an energy efficiency strategy. And this is where Lee's going to take take off later in about 15 minutes. And part of an energy efficiency strategy is energy audits. And after an energy audit, then you've got to develop a scope of work, look at financing, move it into construction, and then after construction is complete, an important step is measurement and verification. Did we accomplish what we wanted to accomplish, and did we save what we thought we were going to save? So these steps answer questions. The first question is, what are we trying to accomplish? The answer is we're trying to get a 15% energy reduction or cost reduction. The next question is, well, what do we have? That's the building inventory piece. What is our starting point? Is the baseline piece. Which buildings should we focus on? That comes out of the portfolio analysis. What's the plan? That comes out of the energy efficiency strategy. What can we do to a specific buildings? That comes out of the energy audit activities. Who's going to do what and how much will it cost? That comes out of the scope development. How are we going to pay for it? Comes out of the financing piece. And then let's make it happen. Comes out of the construction piece. And then finally, did it work? Did we save what we thought we were going to save? And if not, why not? We've got to find the root cause of why we didn't save what we thought we would and fix it. So a typical energy audit includes the benchmarking, the baseline, and an audit. And you can see why just having an audit is not enough. The building inventory piece and the benchmarking piece has been under evaluation. It's been in process for a number of years. AHFC, Alaska Housing Finance Corp, has an ARIS database, and state agencies and a lot of your buildings have been input into that database. Alaska Energy Authority has a community energy model, and part of the RACI process program was building inventory, acquiring a building inventory and getting some benchmarking data. The regional planning efforts that have been underway for quite a while, and some of the Department of Energy has a START program. Part of that was creating plans and strategies. And the most comprehensive vehicle, I guess you could say, for energy efficiency is what's called an ESCO project. ESCO stands for Energy Service Company. Amber Donahue from Siemens is going to be talking about ESCO projects. Siemens is an ESCO. In that case, all of those pieces are included in the project. Portfolio analysis is kind of an orphan here. It's not dealt with very much at all, and I'm a big proponent of it, so we'll get into that in a little bit more detail. So why energy efficiency? And how much is it going to cost? How much can I save? And what happens if I do nothing? So the why, the first piece that I look at when we talk about energy efficiency is, well, where are you on the energy efficiency curve? There are certain energy efficiency measures. I'm going to call them EEMs. They're also called energy conservation measures, ECMs, but I'll use the term EEM. There's certain EEMs like setback thermostats and air sealing that generate a large savings. And then as you move up the curve or to the right, the EEMs start to generate less and less savings. That doesn't mean that they're not important. It just means that the immediate savings is less. Air sealing and setback thermostats are commonly the quickest return, highest savings measures in small buildings. If you've got a larger building with mechanical ventilation, meaning air handlers, then oftentimes and commonly air handling issues, the amount of outside air that you're bringing in, the amount of exhaust air, et cetera, those are going to be the biggest bang for the buck EEMs. But in the smaller buildings, it's going to be setback thermostats and air sealing. And then following that is lighting. In buildings with high amounts of refrigeration, like stores, village stores, refrigeration is going to be a big one. And then envelope upgrades, even though many buildings need them, they're not a high return, quick payback item. They're typically a 20 to 30 year payback. So you can find yourself on this curve. If you have manual thermostats, old T12 lighting, building has not been air sealed, you're down at the lower left corner where the zero savings mark is. If you've implemented setback thermostats, then you're starting to crawl up that curve. If you've air sealed the building, you're going higher on the curve, etc. So the first question is, where do I fall in the curve? Kwethluk was one of the 5 communities in Alaska that was awarded a START grant, or activity technical assistance through the START program. START, I can't remember what it stands for, but again, it's a Department of Energy program through the Office of Indian Energy, I believe. And what we did, I was part of the team that went into Kwethluk and performed the analysis there. What we decided and what they approved was a community-wide efficiency program. What can we do across the whole community to affect energy consumption? Excuse the noise in the background. Sorry. Okay, I'm back with you. Excuse the technical difficulties. So what we found was the average homeowner's electric cost is $1,200 a month. Their average fuel cost is $4,000, and the total non-residential energy costs in the village is about $500,000. The total residential energy cost is about $1 million. This was across 188 homes and 25 commercial buildings. And the goal in Kwethluk was to implement 4 EEMs, which included setback thermostats in every building, air sealing of every building, LED lighting throughout the entire community, and let's up the insulation in the attic to an R60. Those were the 4 what we call low-hanging fruits. The savings for the average homeowner would have been, or is calculated to be $515. The average cost is just over $2,000. The payback is 4 years. On the non-residential side, the average savings was about $3,800 per building. The average cost to upgrade the building is about $15,000, and again, the payback was 4 years. The total community-wide upgrade cost is just over $750,000, and the savings is about $190,000. And the savings breakout you can see over to the left there. So this example is presented as a way to show you what's possible in the village or in a community, a rural community, if you look at it from a community-wide standpoint. Overall, it's just under 13% savings in the community for, again, the 4 simple lowest hanging fruits that are available in just about every community. So comparing that to doing nothing, the chart over on the left is the green line represents doing nothing, and the black line represents implementing these 4 EEMs. You can see that 4 years out is where they cross over. That's the 4-year payback. And at the end of roughly 14 years, 15 years, the difference between those 2 lines is about $7,800, almost $8,000, which means that by the year 2030, the average homeowner will have spent $90,000 versus $83,000 on energy costs if they did nothing. On the non-residential side, the graph over to the right, the difference is quite a bit larger given the annual costs. The average non-residential building owner will have spent $350,000 had they done nothing versus $300,000 had they implemented the EEMs. And this includes the cost of implementing the EEMs. That's why the black line in the year 2016 is higher than the green line because it includes the cost of implementing the EEMs. So this is what happens if you do nothing. You continue to spend money, more money each year, and cumulatively you end up spending a lot more money. So the difference is, I said 7,000 on the chart to the left. It's actually 6,200 and 46,000 for the chart on the right. And I consider that thrown away money because you'll never get it back. So the steps in an energy efficiency process. Let's take a look at these three first. Putting together an inventory of your buildings is pretty simple. You need the name, the address, the size of conditioned space. So what that means is if you've got a building with an unheated garage, that unheated portion is not conditioned, so it doesn't count in the size. You need the use and occupancy, what's the building used for and how many people are in it. And is it occupied? Sometimes it's vacant. And then gather together the electric meters, the oil accounts, if there's natural gas involved. And then what you're going to do with that information is start to establish a baseline. I like a 3-year baseline of electric consumption. You'd sum all the meters if there's more than 1 meter. 3 years of fuel oil deliveries. Typically, fuel oil, in terms of oil, you're going to be looking at deliveries and not consumption, unless you have a cumulative meter on your day tank, which is strongly recommended. So there's going to be some discrepancies in fuel oil deliveries. If, for example, if in December of 2015 you filled up the tank, but in December of 2016 the tank was empty, you're going to have a difference there, so you'll want to average that. You can take this information and put it in a spreadsheet, or you can upload it into the ARIS database, and the folks over at AHFC can help you with that. And then there's a federal tool developed by the Department of Energy called EPA Portfolio Manager. That's basically equivalent to the ARIS database, but it's on a national scale. You can input your utility, your electric, your fuel oil, etc., into EPA Portfolio Manager on a monthly basis, and it gives you trends and charts. When you do, if you are going to use a spreadsheet, it can get pretty complicated pretty quickly. There's a lot of data. This is a spreadsheet that has about just under 3 years of data, fuel oil and electric, for about 12 buildings in Quinnahock. Benchmarking and portfolio analysis. Benchmarking is when you compare your building to other buildings in the community that have a similar use and occupancy. And if there aren't any in the community, then you need to go up into a regional look, and if there aren't very many in the region, then you've got to go statewide. What I use to compare buildings in a benchmarking phase is heating degree days, HDDs. A heating degree day is a measure of the severity of the cold weather. To give you an example, there's roughly 20,000 heating degree days in Barrow, and there's about 8,000 in Juneau, and roughly 12,000 in Anchorage. So as you get colder, you have more days of heating and more degrees of heating. And I'll talk a little bit more about that in a minute. The two measures of comparison that we use in benchmarking is the EUI and an ECI. EUI stands for Energy Utilization Index, or the Energy Use Index, and the ECI stands for Energy Cost Index. The ECI is not very valuable across regions because the cost of, for example, oil can vary from $10 a gallon to $2.50 a gallon. But within your community and within your own building inventory, an ECI is valuable because the costs are roughly the same. The portfolio analysis looks at cost and efficiency, and it includes other considerations. For example, how much money are you spending on the building? And the portfolio analysis will really inform your decisions with respect to energy audits and deeper assessments. And the portfolio analysis leads directly into strategy. This is an example of a number of buildings. I just picked office, library, museum, community centers, all similar type buildings. The gray bar at the top of each building is the number of heating degree days. And you can see the top building there, Barrow, that's the shipping and receiving building in Barrow, has a lot more heating degree days than the courthouse and the city hall in Yakutat. The orange line is the heating EUI. And roughly the heating EUI should be equivalent to the number of heating degree days. You can see that in Barrow it's fairly close. In the Unalaska Library, it's pretty close. The Yakutat Courthouse is pretty close. But in the case of the community center in Unalaska and the city hall in Yakutat, you can see that the heating EUI is significantly, it's 2 to 3 times higher than the HDD. And that tells me that those buildings, they've got issues going on in the heating systems in those buildings, and we need to look at that. The electric EUI is the blue line. And you can see there's quite a broad variation there. The Yakutat Courthouse is the lowest. Community Center, again, is the highest. Electric EUI is often dependent on the number of hours that the building is open and what's going on in that building. Stores, as I mentioned before, with higher refrigeration loads are going to have a higher electric EUI. But these buildings are all fairly similar. So the electric EUI should be fairly close to each other. And you can see that it's not. So this is one piece of a benchmarking and portfolio analysis. This is another piece. This is, I mentioned ECI, the Energy Cost Index. And these are, I did a portfolio analysis for the city of Unalaska and the school district down there. These are the buildings that we looked at. And you can see that on a by the way, ECI stands for cost, or I can't get the word. It's dollars per square foot of building. So how many dollars are you spending on energy per square foot in each of these buildings? And again, I've split out the heating and electric, and you can see that the heating ECI is fairly consistent across all of the buildings except that Baylor building, which is their solid waste processing building. And the electric EUI, it varies quite a bit. The high schools kind of average. The wash building over to the right, that's pretty high. And that's heating. So that wash building, what that is a building that they use to wash down their heavy equipment, and they've got a pressure washer that's got heated water, so that's where a lot of that heating is coming from. Anyway, this ECI comparison, as opposed to the prior slide, which was the EUI comparison, gives you a little bit different perspective. Just tried to go backwards, but it didn't go. Okay. There it is. Well, no. So the third measure that I use in the portfolio analysis is what I call an E factor. Let me see if there we go. So you can look at some of these buildings like the Yakutat City Hall or the Unalaska Community Center. The Yakutat City Hall is actually a very small building, and the EUI, by the way, is the units are kBTU or 1,000 BTUs per square foot. So again, it's broken down on a per square foot basis. You can see that, for example, the Yakutat City Hall has a very high heating EUI, but that happens to be a very small building. So what I do is take the EUI and multiply it by the total energy costs in that building. You can see that the high school and pool back here, from an ECI standpoint, it's not that high. But when you look at the size of the building and how much is actually being spent in terms of gross dollars, that building has got the highest, what I call E factor. The Baylor building is high. This is what I use to determine what buildings should we be performing energy audits on, which buildings should we be looking more deeply into. Because you can have a small building, for example, let's say all the way up on the other end of this chart, the Burma Road Chapel. That could have it could be a very inefficient building, but you're only spending $5,000 a year on it. It's not where you're going to pay attention. High school in hand, a fairly efficient building, but you're spending $500,000 a year. So that's what this E factor considers. It's the cost and the efficiency. And again, this is what I use to determine or to inform a deeper analysis where we go with energy audits. So to finish my section here, the benchmarking, baselining, and portfolio analysis feed the owner's goals, community goals, maintenance, and capital expenses. It informs all of these different other factors. Lee's going to talk about strategy and planning and energy audits. Financial considerations will come later, I believe next month. So in my mind, and in my world, this first section, the benchmarking, establishing a baseline, and performing a portfolio analysis, that informs where you're going to go and what you should be doing moving forward with an energy efficiency program. And with that, I'm going to turn it over to Lee, who's going to take it from here. Thank you.
All right, thanks, Jim. This is Lee Bolling here, and let's see if I can get my control these slides here. I believe I can. So I'm a mechanical engineer with Coffman Engineers, and just a little bit about myself. I'm born and raised here in Alaska. I've been working in the energy efficiency field since about 2008, so it's about 8-9 years. Coffman Engineers, we're a multidisciplinary engineering firm. We do everything from alternative energy, sustainability, to civil and structural engineering, electrical engineering, mechanical, and we have a kind of a group of folks around the country that specialize in commissioning and energy efficiency. You can kind of see in that list right there. We have quite a different certifications and stuff like that. So we've definitely had a wide experience of projects, from projects in rural Alaska all the way to things in San Francisco as well. So what I want to talk to you guys about today is really take what Jim says and go to the next level. And Jim really focused on that benchmarking and picking the buildings. Okay, so now we're going to talk about energy audits. So now that you've had someone like Jim look at all the different buildings, and we picked, let's say, the top 2 or 3 or 5 or 10 buildings that you want to focus on. Now we're going to go into the energy audit and what is involved there and why that's important. Now the first thing to talk about before we get into energy audits is, what is your goal? And I feel like a lot of times people don't talk about this, but it's very important because each building is different and each owner of the building is different as well. So I'm going to run you through just a couple of different people, kind of stereotype people that, clients that I meet while I'm doing these projects. And the first one is the business owner that is all about the Benjamins. All right, he's a very shrewd business owner that is very interested in cash flows and needs to make sure that he's paying his bills. He wants to make sure that he's getting a quick return on his investment. And so the all about the Benjamins guy is more interested in short-term paybacks, maybe 1, 2, 3 years, 4 years. Once you get outside of 5 years, he's not really interested in that because he may sell the building or do something else from there. The next person that I meet a lot is a person that I like to call tenants are number one. So they, energy is important to them, but it may not be the biggest important item. the actual quality of life in the building may be more important than energy. And so you have to balance that. You know, they could be someone, let's say there's a clinic in your community, or a school, or a hospital, or a senior center. You know, you want to save energy there, but you also don't want to reduce the quality of life in that building, and that's very important for you know, user comfort and satisfaction. You know, we spend a lot of time in buildings, and we want to make sure that they're comfortable for us. The other type of person I meet is I like to call the long-term spaceship man, or Scotty, and they have a very long view of their building. And this might be someone like yourself in rural Alaska, where you have a building that you know is going to be around for a long time. A lot of times it's a school district, so the schools in your villages or your communities, or the water plant, for example. They're going to be around there for a long time, and so they have a much longer time frame that they're looking at improvements. You know, the long-term spaceship man, you know, he could look at, you know, 10 or 20-year paybacks and be totally comfortable with that. And then there's always somebody that is just stoked. You know, someone that is just pumped on energy efficiency. They may not care about the money side as much. They're more cared about the environment and carbon reduction. And so at the end of the day, usually if you're in charge of a building, you're kind of a mixture of all of these kind of different factors. And so it's important for you to kind of think about, you know, which one of these do you more identify with, and what is your plan moving forward. So now let's talk about energy audits. So now that we have the client's goal, each one of these clients on the left has a different goal, but at the end of the day, the energy audit is going to match that client's goal, or the client's, you know, goal with a solution. And so the first step is a level 1 energy audit. We're going to talk about several different audits, and level 1 is the easiest audit for someone like myself or Jim to do, and it's called level 1. It's a walkthrough audit, and it's usually involved a couple hour site visit to the building, walking around, and really looking at those low-hanging fruit. You know what Jim was talking about before about, you know, LED lighting, air sealing, how is the building controlled? And there's a lot of things that an auditor can find just within the first, you know, 5 minutes of being in a building that can make a huge difference. So walkthrough audit is a very good thing to do. It's fairly low cost because it doesn't take a lot of effort from our part. But the most important part about getting any audit, no matter if it's level 1 or 2 or 3 or something else, the key is to get to action. Okay, an audit itself doesn't necessarily save energy. The audit is your roadmap. Okay, so it's a roadmap that you take, and it helps you actually do action. And once you complete some type of action, then you reach your goal. So that's a lot of times people forget about that. You know, we'll give audits to folks, and they'll say, "Oh, thanks, we got this audit. That's great. Now we'll sit on it and not do anything for a year." So that's not a very good plan, because the audit is not saving you energy or money. You need to take that audit and you need to go through the list of tasks and develop a project and actually make something happen. So the next level of audit is a level 2 audit, and this is a little more in depth. It usually takes, depending on the size of the building, and it can take, you know, 1 to 2 days going through a building. And really, we're getting into the detail of all the different energy using equipment there. So motors and boilers and fans, and taking information from each one of those pieces of equipment. And once we get all this information and we talk to the person that's actually operating the building, we can go back to our offices, pull out our fun Excel spreadsheets or energy model, and plug it all in and start running some calculations to really figure out what's going on. With this level of audit, the level 2 audit, there's more intense or detailed cost estimating. So really trying to nail down, okay, what is going to be the cost from this improvement? Because remember, it's a balance. You're going to save energy, but it's also going to cost you money to buy improvements to get those savings. So it's a balance there, and that's where the payback comes in. Quicker payback items are better to go through. But at the end of the day, you still need to get to action, and you still need to get to your goal. So just for an example, the All About the Benjamins guy, he may just want to do a level 1 audit and get the low-hanging fruit and go to action. Whereas, you know, long-term spaceship man, he may want the level 2 audit because he wants a more detailed engineering analysis, and he can deal with some longer payback items. The last level of audit is a level 3 audit, and this is the most detailed audit. I've personally only done probably a handful of these audits. Most of the audits I do are level 1 or level 2, and the reason is because most people don't want to pay for the extra effort that goes into doing a level 3 audit. But level 3 audit is much more detailed site visit, and really it's taking all of that information and dumping it into a computer model and running that model for every hour of the year, so for 8,760 hours in a year, and pumping out results for you. This is usually used in large capital improvements, and usually for, you know, larger buildings, you know, maybe the school in the community or the water plant, and it really involves a more refined cost estimate, and it's definitely the most time-intensive audit. One example that I always give with this level 3 audit is this is actually a building here in Anchorage that I worked on, and there was a large office building, and the owner of the building hired us to do a level 3 audit and said, hey, you know what, this guy has this tinting to the windows that I want to put on, and you know, it's going to cost a lot of money, but he promises me it's going to save a bunch of money. We say, okay, well, let's model this and see what happens. And what we found is that indeed, that, you know, putting that window film actually stopped a lot of heat from coming in the building, and the cooling system didn't have to work as hard, and so they actually saved a lot of electricity. But on the flip side, they had to burn a lot more natural gas to compensate for that heat that they lost. And at the end of the day, there really wasn't that much savings, and it was going to be like I think it was a 100-year payback for doing the improvement. So sometimes it's nice to do these audits to figure out, you know, what doesn't work. Sometimes what doesn't work, knowing what doesn't work is just as important as knowing what does work. I think I'm having a little problems here trying to move my slide forward. Hold on a second. There we go. Okay, so the last thing I want to talk to you about is something called retro commissioning. And retro commissioning is similar to an audit, but it's a lot more hands-on. And typically it's for the larger buildings in your community, like the school, for example. And really it's getting in there and tuning up the building. You see this picture of this old Alaska truck right there, and that truck needs a tune-up, all right? And you can imagine your building getting a tune-up and figuring out what's actually going on and getting it working right. And commissioning, the term commissioning comes from shipbuilding. So you can imagine, let's say you have a 50-foot commercial fishing boat out in Bristol Bay that someone's building. And it's probably a good idea that before that ship goes out and sails in those seas, that they've tested all the different components on that system. You need to make sure the steering works, make sure the radios work, make sure the engine works. And a lot of times this isn't done with buildings. You know, a contractor will build a building and then hand it over to the person that bought it, but they won't test all the different systems to make sure they're actually working right. So that's commissioning. And retro commissioning is the act of doing that whole commissioning project on an existing building. So you may have a building in your community that was never commissioned or hasn't been retro commissioned in a long time, and those are great buildings to go back to and find out what's going on. A lot of times this gets into some pretty intense details with the control contractor that works on the building. So like the school may have a very complicated control system. And sometimes what we find, first thing we'll look at is we'll dive into that code and we'll see, hey, what's the schedule of the fans and the boilers, how are things working? And a lot of times it'll be one line of code that will end up changing, and we can save, you know, tens of thousands of dollars just with one quick line of code that would, you know, allow the fans to turn off at night instead of having them run all day long. But at the end of the day, all of these things are trying to get you to your action and then to the goal. So every part of an energy audit involves taking a building and auditing the energy, right? I mean, energy audit. So we're going to pretty much figure out where all the energy flows in that building. Now here's an example building for you. This is a pretty big building. You probably don't have a lot of these in your community or any at all, but I wanted to show this to you because it gives a good example of all the different components that can be in a building. And this is a building that you know, could be in Fairbanks. It's 25 years old. It's 50,000 square feet, and they spend overall about $225,000, $100,000 on electricity or on energy every year. So $153,000 on electricity, $72,000 on heating oil. And so that's a lot of money, and we need to figure out where all this money is going. And like Jim said before, you know, you can use different indicators to rate these buildings. This is on a energy cost index, ECI, of $4.50 per square foot. So over a whole year, if you divide all the energy costs by the square footage of the building, it costs you $4.50 per square foot for a whole year. And in the Fairbanks, for example, buildings can range from about $2 a square foot all the way up to $8 a square foot. So there is room for improvement for this building. Nice thing on the left is you see the pie chart, and this is a great way to look at what's actually happening. And if you can see on the far left, the biggest user of energy in this building is space heating. So that's heating oil for space heating. That's about $64,000. Interior lights are the next biggest. The blue on the right, for some reason that's not coming through, but that's all the plug loads and office equipment that's used in the building. You also have pumps and ventilation fans, and one thing a lot of people don't think about is server rooms as well, or air conditioning. But this gives you a good idea of what to focus on. You know, for this building, we're going to focus on heating and lights, and probably controlling their ventilation system. If you look at the very top, there's a hot water that's used for, you know, washing hands. And in this building, there's only $1,000 worth of use in hot water. So that's kind of a red flag for me that says, hey, you know, we probably shouldn't spend a lot of time looking at how to reduce hot water because there's so many other more important things to look at in this building. Now, this is an example of a report that you would get from an energy auditor like myself or from Jim. This is actually a project I did in Cayena this last year, and I think Nelson may be on the phone. I worked with him in Cayena, and Cayena was an awesome community to go to. I had a blast there. It was beautiful weather. It was like 90 degrees. It was crazy. I went fishing as well. So Nelson, you got a great community up there. But in your report, you know, the first thing you usually get is, you know, inside the report there's going to be all sorts of details about the mechanical systems and the lighting systems and the envelope. But at the end of the day, you kind of want a list of just, okay, what are those energy conservation measures that I want to actually, measures that I actually want to do, and have them ranked. And we usually put that in our executive summary. And you can see some of the things that are the most important are adjusting thermostats, replacing incandescent lights with LEDs, replacing CFLs with LEDs. Also, in these studies, the auditor may find things that you should look on for future things to do. Like one of the things we found was that the school is actually a very big building there and quite complicated, and that would be a perfect candidate for doing a retro commissioning project there. Also, doing a lighting design at the school could be great for improving to LEDs. One thing about lighting projects is that when you have a pretty big building, it's usually a good idea to bring in a professional lighting designer. It's easy for an auditor to pick different lights and just replace them in kind, but sometimes a better solution is to just do a total redesign of the system, and you can get better quality light and energy savings at the same time. Usually when we're doing these audits, these are the top 5 low-hanging fruit that we find. So you should be looking at all of these for all of your buildings. You don't really need an energy auditor to tell you this, but so I just wanted to give it to you. Pretty much, the first one is just how is the building controlled? So that's your thermostat. Turning down your thermostat or doing a night setback where the thermostat turns down during the nighttime hours is great. One thing to be aware of is that if there's a power outage, your thermostat will probably reset itself, and so you have to go back in there and reprogram it. Second one is LED lighting. LED lighting's come a long ways, and improvements with LEDs is really great to do. Next thing is weatherization, so filling in cracks, air sealing, all of that good stuff. Fourth thing we usually find is controlling motors on pumps using ECMs or VFDs. VFDs are variable frequency drives. And then the fifth thing is reducing the amount of excess outside air. So if you have fans that are bringing in ventilation air for people to breathe in the building, figuring out how much air you actually need per code and to make a healthy building, and not bring in any more than you really need to, because that increases costs. So it looks like we're at about 10:52. I have 2 more slides that I'll run through pretty fast, and then we can go to questions after that. So we have the client's goal, we have your goal, we did the energy audit, and now we want to get to action. And some clients can take that energy audit and go straight to action and reach their goal. But a lot of times what we find is that a client may not have the manpower or just the time and energy to get to that action part. And that's where this orange circle called project development steps in. And project development is really taking that list of improvements from your energy audit and getting them in a form that you can actually get a contractor to bid on the work and come do the work. So really that's creating the scope of work. Okay, we're going to replace the lights in the school, but how many lights are we going to do it? Where are the lights going to be stored? What kind of light are we doing? Where's the contractor going to stage his equipment? Also, you may need to obtain design and engineering costs. Before the contractor could install these lights, or let's say a boiler system, you would need to get a stamp design from a professional engineer, mechanical engineer. So there's costs associated with that engineering, and so that's something to look at. Once you have engineering design, it really helps. You have a scope of work and you have design drawings if you need them. Then you can give that out to a contractor. You give it out to 3 or 4 or 5 different contractors and get bids on the work. And that's a great way to make sure the contractor understands what the project is and to see what the range of prices are. A lot of times there'll be a wide range in costs from a contractor, and from low to high. And usually you don't want the lowest cost, and usually you don't want the highest cost. You want somewhere in between. Like they say, you get what you pay for, but it's a good way to figure out what's going on. And looks like we had something pop up there. And the great thing about this RACI program was that it wouldn't have been efficient for an auditor like myself to just go out there and do one building. So what they did is combine these into a bunch of different buildings. I think I looked at 10 buildings in Guyana. And so that's the economy of scale. And also, if you do your lighting projects, try and do them in all the buildings if you can at once, so you can have one contractor out there that does all the work. Financing is another part. And we're going to talk about that more in part 2. Amber McDonough and Peter Beardsley will go over that. But a lot of times if you want to get financing, you need to get this project development side all taken care of so that someone can trust your findings, trust the cost estimate, and will loan you the money to do these projects. So that's about all I have. One last thing, I do see that there's a lot of hurdles out there when we do these projects. One of them is the waiting game. A lot of times people want to wait for someone else to pay for an audit or pay for improvements. But the reality is that these improvements are great investments. And if you have the money and have a good auditor, they can help guide you through making a good investment. Also, like Jim said before, if you're not paying for an improvement, you're actually paying for wasted energy. So you got two hands, right? You got 2/5 of cash. You can either have 1/5 of that cash, you can have it burning up and not using it at all, or you can take that money, instead of burning it up with wasteful operations, you can actually use that money to pay for an improvement. And the last thing is to think about energy efficiency as an investment. And like you would invest in a stock or a bond, this is a great way to get a return on your building that you own that you can't get anywhere else. So with that, I'm done talking, and let's open it up to questions, and we'll go from there.
Thank you. We do have one question come in that says, hold on, let me scroll up. Would it be possible to develop a spreadsheet for a customer to fill out and send in to get a low-level energy audit?
This is Jim. I'm not quite sure I understand the question. Are they asking to have an audit from a distance based on a spreadsheet? Let's assume that that's the question. And the answer would be, you can tell some of what's going on in the building by looking at a monthly graph of electric and oil consumption. You can get some suspicions, I guess I would say, from looking at a graph, but ultimately you probably need to do a site survey, at minimum a level 1 walkthrough, to either confirm those suspicions or find out that they're wrong and find out what actually is going on. You could, based on some kind of a benchmark, you could tell whether that building is performing as it should, or it's 20% above average from the standpoint of cost and consumption, or it's 30% below average. So you could get that kind of information from a spreadsheet with monthly energy consumption data for 2 to 3 years.
Yeah, this is Lee. I agree with Jim. Having an on-site site visit is definitely the best way to really dive into your building. And I guess for myself to make recommendations and actual like savings calculations and costs, that's what would need to happen. On the other hand, if someone does have a building and they just want to talk about it and get kind of high-level improvements without any, what the actual numbers of what the savings are going to be, that's something you can do over the phone and talk about the operations of the building. But that's a pretty high level. It's hard to really see the whole building from a distance, like Jim was saying.
Perfect, thank you. And then we have one more question. When presenting audit findings to the decision makers under the RACI projects that Jim and Lee have been involved in, what seem to be the factors that most influence their decision to act on the recommendations?
This is Lee. I can speak to that a little bit. I haven't worked on this next step of the RACI yet with decision makers, but I do know from my other projects, pretty much one of the main decision points is the payback. when are we going to get the money back that we're going to spend on this? And it is a good idea to do the quicker payback items first. You know, just get those out of the way, get them done. Once you have those items done, then move on to longer term payback items. So I would say that the economics are the most important factor that I see with clients. I don't know, Jim, if you want to add anything more to that.
Yeah, I'll stay in the economic answer because I agree with that, but I'll broaden it out a little bit. I think I worked with Port Lions and Sandpoint, and Sandpoint ended up not submitting for the Phase 3 funding, and Port Lions did and was awarded Phase 3 funding. What they then needed to do, because the funding wasn't for all of the recommended EEMs, they needed to go back into the list of EEMs, and I worked with them on that to select the most appropriate ones based on their situation. What can we do with it? That's what dictated which EEMs they implemented.
You know, another thing to add to this as well, if you are meeting with a decision maker about what projects to do, bring in the auditor that actually did the report. You know, having someone like Jim or myself there as well at the table can add value by explaining, you know, the economic sides, why it's important, and how it's going to save money. So another thing to think about.
Perfect, thank you. And that's all the questions that we had come in. So I just want to say thank you to Lee and Jim for speaking. And as a reminder, this webinar will be available online at the RACI website in mid-February. And this concludes the webinar.
Thank you all.
Yeah, thank you.